Okay, today we're going to take a look at simplifying algebraic expressions. Now, the last couple of weeks we've been looking at solving algebraic equations. When we were solving equations, what did our solutions typically look like? Give me an example of what our solutions looked like when we were solving an equation or an inequality.
Y equals x.
Probably wouldn't have y equals x.
Y equals 24.
Y equals 24 though, sure. Okay? Or negative 3 is greater than y. Okay, that's what our solutions look like. When we were solving, we were finding the value for the variable, or the value of the variable that makes the equation or inequality true. Okay, we're trying to find what makes that equation or inequality true. Okay, if I put 3 in place of x, the equation's true. Okay, and that only works because we have that equal sign, or we have that inequality sign. And we know what's going to go in place of that variable to make that equation true. When we're simplifying, it's a little bit different. When we're simplifying, we're not trying to find what the value of the variable is. Okay, if we take a look at each of those examples, there's no equal sign. Okay, so any value of x in example 1 can make this expression true because it's not equal to anything, it's just an expression. Okay, but what we do want to find is what it looks like in its simplest terms. Okay, when we are simplifying, what we're trying to do is write the expression using as few characters as possible. Okay, we're not trying to change what the expression is worth. We want it to still represent the exact same thing, but we want to do it with as few terms as possible. Okay, think of it as you're kind of editing a Twitter post. Okay, because you have that limit. You're only allowed to use so many characters. Well, we're trying to get this expression to fit into that space as well. We're trying to write it with as few characters as possible. So what it comes down to is pretty much two simple things. Okay, number one, the first thing that needs to happen is I need to eliminate parentheses. Need to get rid of them. Okay, just like a standard order of operations problem from when you were in 6th grade, we need to get rid of parentheses first. Now, in 6th grade, all you had to do was, add or subtract or whatever was in those parentheses, you did it. Okay? But when we're looking at these expressions, I can't add 2x plus 3. In that first example, I can't do 2x plus 3. Why not, by the way? Why can't I do 2x plus 3? Aiden?
You don't know the value of the variable.
I don't know the value of the variable. Okay, those are not like terms. I cannot add a constant term and a variable term. So I'm stuck with 2x plus 3. But what can I do on example 1 to get rid of those parentheses? What did we spend the last couple of days doing?
Distribute the 6 to both.
I can distribute the 6. Okay? And guys, most of the time, that's what eliminating the parentheses entails. You distribute. Okay, the other thing that has to happen when we're trying to simplify an expression, we also want to combine like terms. Okay, and that's an expression that you're going to hear a lot. Okay, you're going to hear combine like terms for pretty much all the math classes that you're taking from now on. Bless you.
Thank you.
Okay, now what makes terms like terms? Well, first off, what does it mean to combine? What does it mean to combine?
Join together.
To join together. That's all it means. You take two or more things and you put them together. You combine them. Okay? What are terms? What are terms? Well, in math, take a look over at this board over here. I've got 4x minus 1. 4x is a term. 1 is a term. Over here, I've got 45 minus 50p. 45 is a term. 50p is a term. Okay, terms are variables, numbers, and products, multiplying, of variables and numbers, separated by plus and minus signs. That's pretty much what it comes down to. Terms are separated by plus and minus signs. Okay, so like terms are terms that have the same variables. Terms that have the same variables. That's the long and short of it. If they have the same variables, they're like terms. Now there's one thing that's super important here that a lot of us are going to skip or get confused on. We want to make sure that we're super clear about it. Okay, we want to make sure that we're aware of this. We need to watch out for negatives. Okay, we need to make sure that we're watching out for negatives. In all of this, we need to watch out for those negatives. Remember, negatives don't really change what we're going to do, but we need to be aware of it. Okay, so let's take a look at a couple of these examples. First off, the directions say to simplify completely. Not simplify a little bit, not simplify halfway, simplify completely. So that means I want to write with as few terms as possible. So I look at 6 times the quantity, 2x plus 3 minus 4. Okay, and the first thing that I know I need to do is eliminate those parentheses. Now we've already said I can't do 2x plus 3. I have a constant term in 3 and I have a variable term in 2x. So I can't add them. But what I can do to eliminate those parentheses is distribute that 6. So I'll have 6 times 2x, bring down that plus sign, and then 6 times 3. Now someone's going to want to say, well, I should multiply that 4 by 6 as well. But that 6 is only attached to what's inside the parentheses. Okay, that 4 is out there by itself. It stays alone. So I'll just bring down that minus 4. Well, 6 times 2x, that's going to be 12x. I'll bring down the plus sign. 6 times 3 is 18. Bring down minus 4. Okay? And now, those parentheses are gone. Okay, so I've eliminated the parentheses. But now I want to combine my like terms. Okay, the like terms are terms that have the same variable. Someone out there is saying, well, there's only one term with the variable, that's 12. But what variable is attached to that 18? What was that? No variable. What variable is attached to 4? No variable. So 18 and minus 4, they have the same no variable. Okay? Constant terms are like terms. We can put all constant terms together. They have no variable, means they have the same variable. Now here's the catch though. The sign in front of the term stays with that term. No matter where we move it around, no matter how we combine them, the sign in front of that term is stuck to it. So this 18 is a positive 18. Wherever it goes, whatever I combine with it, however I treat it, that has to stay plus 18. Okay? Then this 4 has to stay minus 4. That minus is in front of that 4, it has to stay minus 4. So I'm going to put these together. Positive 18 minus 4, and that's going to leave me with a positive 14. Now I didn't touch that 12x, so it's going to fall right down to the next line. Now I can't just have 12x 14, that's kind of gibberish, or actually that would mean 12 times x times 14. So I need an operator in here. Well, that's a positive 14, right? So what operator do you think I'll use? Yankee? Plus. 12x plus 14. Okay? And there we go. Now the question is always, how do we know we're finished? Well, you know you're finished when there's no parentheses and there's no more like terms that you can combine. Okay? The only 2 terms I have left are 12x and 14. I've got one constant term and one variable term. I can't put those together. So I'm stuck with 12x plus 14. Okay? Let's take a look at number 2. Number 2, I have 1/2 times the quantity, 2 minus 8v, close the quantity, plus 5. Now someone out there is going to say, that's a fraction, what do? We do the same thing we do every time. Okay? I want to eliminate the parentheses, and then I'll combine my like terms. Okay, so to eliminate those parentheses, I'd love to do 2 minus 8v, but I can't. Okay, 2 is a constant, 8v is variable. I cannot add or subtract them. So the only option I have to get rid of those parentheses is to distribute that 1/2. So I'll take 1/2 times 2, bring down the minus sign, 1/2 times 8v, bring down the plus 5. So now I have to deal with that 1/2. Okay? Well, it's not as big a problem as you think. We're just going to flip over to the back and do a little bit of scratch work. I need to do 1/2 times 2 and 1/2 times 8v. So let's do this. 1/2 times 2. How do I multiply it by a fraction? Integer times fraction, Camaro.
You have to add a denominator to the integer.
Good. So what does that 2 become?
2 over 1.
2 over 1. Then how do I multiply?
Straight across.
Straight across. 1 times 2 is 2. 2 times 1 is 2. And what's 2 over 2 equal, Camaro?
1.
1. So, whoop. This right here, 1/2 times 2 becomes 1. I'll bring down the minus sign. And then I have 1/2 times 8v. Well, let's go here again. 1/2 times 8v. Ethan, what's going to happen here?
You have to put 8v over 1.
Okay? And now what?
Now you can multiply.
Okay, and what will I get?
8v over 2.
8v over 2. And what is that going to equal?
4v.
Just 4v. So I'll come back to the front. And I've got 1 minus 4v. And I'll bring down that plus 5. Step 1, eliminate parentheses. Done. Step 2, combine like terms. So I want to put my like terms together. Now like terms again have the same variables. The only variable I see up here is the v. And I only see it once. But I've got 1 and I've got 5. They have no variable, which means they have the same variable. Constants are like terms. Now remember, the sign in front of the term stays with that term. So this minus sign is attached to that 4v. So all I have is this 1 and this positive 5. What do I get if I do 1 plus 5? I hope everyone here tells me
6.
Thank you. Okay, so I've got the 6, and I haven't touched that minus 4v, so it's going to come right down to the next line. Now I've got a constant term in 6 and a variable term in minus 4v. I can't combine those, so I'll leave those the same. Now, there is another possibility here. Okay, what if I wanted to have the variable term first? What if I wanted to put negative 4v as my first term? What would my second term be? What do you think, Cubby?
6.
It would still be 6. Now here's the real question. Should I do plus 6 or should I do minus 6?
Positive 6.
Positive 6 means we're going to keep it plus. Hmm?
Can't we also like make it finish? Aren't they both divisible by 2?
Okay, so they are both divisible by 2. So we could factor out a 2. That's what we were doing yesterday. We're using distributive property to factor out GCFs. But if I factor out that 2, then I'm going to have parentheses again. Because then I'll have 2 times the quantity 3 minus 2v. And I brought parentheses back. And we don't want parentheses. Okay, to simplify means to eliminate parentheses. We talked yesterday, there are times where having that GCF out front makes our job easier. But right now, we want to get rid of parentheses. Okay, so we're going to leave it as 6 minus 4b or negative 4b plus 6. Okay? And we can't simply divide that 2 away, because if we divide that 2 away, it's a different expression. It doesn't mean the same thing anymore. Okay? Okay, let's take a look at number 3. Number 3, I have negative 3 times the quantity, y plus 5, minus 2y plus 1. So I've got an extra term here. No big deal. Step number 1 is still eliminate those parentheses. Okay? Now I'd love to do y plus 5 and say that that's 5y, but what does 5y mean? What does that mean? Caitlin?
It would mean that you added split.
If I wrote, I'd love to put those two together. Y plus 5, and I'd love to call that 5y. But if I did that, that'd be wrong. Why would that be wrong?
Because one of them doesn't have a variable, and that one does. Because that one's 1y.
True. What else?
It's like they're multiplying each other.
This one says multiply. 5y means 5 times y. Y plus 5 means y plus 5. Okay, plus and multiplied are two totally different operations. Okay, so I can't just call that 5y. Okay, so what's my only option here to get rid of those parentheses? It's my only option to get rid of those parentheses. Distribute the negative 3. Okay, when I'm distributing a negative, I like to put a circle around it so I don't lose sight of the fact that it's negative. Now, Jamie, what's that going to look like when I distribute that negative 3?
Negative 3 times y plus negative 3 times 5
Good. Okay, what else?
minus 2y plus 1.
Good. Don't lose the rest of it. Okay, all that stuff that we didn't do anything with, got to bring it right on down to the next line. Okay, Lena, can you tell me what the next line might look like? Or should look like, I should say.
Negative 3y plus negative 15 minus 2y plus 1.
Good. Okay, negative 3y plus negative 15 minus 2y plus 1. All right? So, parentheses, gone. Now I need to combine my like terms. Well, I actually have two pairs of like terms this time. I have minus 3y and minus 2y to start with. Okay, so I'm at negative 3y and I'm subtracting 2y more. Where's that going to land me?
Negative 5y.
Negative 5y. Excellent. Now we said we have another pair of like terms here. Okay, I have negative 15 and plus 1. What's that going to give me when I combine those two?
Negative 14.
Negative 14. So we're going to say negative 5y minus 14. No parentheses, no more terms we can combine. We're done. All right, what questions do we have on any of those three? You sure?
Shouldn't it be negative 14?
It is negative 14. Okay, it's minus 14. Remember, the sign in front of the term stays with that term. Okay, so right here, see how this was plus negative 15? Okay, so this negative 15 is the powerhouse. This plus 1 only brings it up to 14, but it's still negative 14. So if I wanted to, I could say negative 5y plus negative 14. Okay, but what would I have to change that plus negative to? Just to minus. Okay, I would just have to have minus anyway. We don't like to keep two operators back to back. Yeah.
So if you could like switch 6 minus 4b around, could you do that for the first question, like 14, or wait, no, on the third question?
As a matter of fact, you could do it on every single one of these. Okay? Addition is commutative. So I could switch this around and make it 14 plus 12x. As long as that 14 stays positive, and as long as that 12x stays positive. Okay? I could switch this around. Okay? And make it negative 14 minus 5y. As long as that 5y stays negative and that 14 stays negative. Okay? The catch is, remember what I said at the beginning, the sign in front of that term stays with that term, no matter what order you put them in. Okay, if there's a minus sign in front of it, it needs to stay there. It's going to end up looking like a negative, maybe, instead of a minus, but it still has to stay there. It has to stay with it. Okay? All right, good questions, guys. Okay, let's take a look really quickly at number 5, because number 5 is about to jump up a notch. Okay, number 5, I still need to get rid of those parentheses first. Okay? And I still can't add 7x plus 5. I can't say that that's 12x. Okay, it's not the same thing. But I don't see anything that I can distribute. You know, someone's going to say we can distribute the 7. Well, we can't because that 7 is not multiplying. This 7 is not multiplying that set of parentheses. Okay? It's out here with a minus sign between them. When we distribute, every time we distribute, guys, we're multiplying through what is immediately in front of those parentheses. What's immediately in front of those parentheses?
Minus sign.
A minus sign. How am I going to distribute a minus sign? Here's the answer. I'm going to treat this minus sign like a -1. When you have a minus sign right in front of a set of parentheses, what you're going to do is distribute a -1. Okay? So I'm going to distribute that -1. And I'll have -1 times 7x. Bring down the plus sign, -1 times 5. Now I didn't touch the 5x plus 7, so I'll bring those right on down. All right, so guys, I'm going to finish this one up real quick. I'd like you to stick around with me. 5x plus 7, bring down the minus, 7x, plus -1 times 5 is -5. Your like terms here, you've got a positive 5x and a -7x. If you put those together, you'll have -2x. Okay, then here I've got a positive 7 and a -5. If I put those together, that's going to be a positive 2. All of my like terms are combined. There's no more parentheses. This one is simplified. Okay, so eliminate the parentheses, which usually means distribute. Combine your like terms if they have the same variable or no variable. And lastly, watch out for those negatives. The sign in front of that term has to stay with that term.